She right?
Yes. What did you know, Miss Campbell?
I wasn't listening.
You weren't? Oh. Well, the only ones that are tricky are the cotangent.
Oh, okay. All right, so derivative of sine is?
Cosine.
Derivative of cosecant?
Negative cosecant cotangent.
Okay, tangent?
Secant squared.
Cotangent?
Negative cosecant squared. No, negative cosecant.
Negative cotangent squared.
What? What?
You and I lie.
Did I say the wrong one?
Yes.
Yeah, I'm thinking in my brain, I'm like, what have I and haven't called out?
Cotangent.
Okay, cotangent. Negative cosecant
Yes, squared. Yeah, you just said it.
Cosine.
Negative sine.
Secant.
Secant tangent.
Did I get them all? I think I did. But I didn't go in any order, so I lost track. Okay, so when we take the derivative of functions containing trig functions, it's important to first determine the types of functions. Do we have a power rule being used? Do we have product rule, quotient rule, etc.? And then, of course, don't forget the chain rule. Okay, so first example. Find the derivative of 2 sine x. 2 cosine x. Can I use the product rule here?
No, because it's just a coefficient. It's not like
I could. I could, but when I did u prime, it would be 0. Okay, so I would still just end up with this one term. So yes, I could use it. It's just a little bit longer process. Okay, find the derivative of 3 sine 2x. 3 cosine 2?
Yeah.
Okay, so I'm going to write that down. But think about that, like that's just a number. The cosine of 2, that means, what's the cosine of 2 radians? And then multiply it by 3, like where's my x? See what I'm saying? Yeah. Okay, so 3 cosine 2x is a good start. Not the product rule. And again, I could use product rule on this one, but it's not necessary because that 3 is not a function of x. It's just a straight up coefficient. But notice how I'm taking the cosine of this function here. And have I taken the derivative of 2x yet? No. Okay, so I'm going to put this in parentheses and then a 2. Okay, so a couple things to point out here.
Wait, why'd you put the 2 out?
Okay, so I put the 2 there because it's the derivative of the 2x. So why have, it's the chain rule. So why have we not been doing that before? Well, it's always just been x. And what's the derivative of x? 1. So it wasn't necessary. But if there's something other than just 1x, the chain rule, we've got to go back and pick up that derivative also. Another thing, why did I not do this? It's not really wrong writing it that way, but wouldn't you maybe be tempted to make that a 4x? Okay, so this way I can see, oh, these are not multiplied. Really, the 3 and the 2 are multiplied. And I'm going to get 6 cosine 2x. Question on that one. All right, well, let's crank it up a notch. 2x times sine 2x. I have to use the product rule, yes. Okay, so here is u and here is v. All right, so let's start with, I'm going to do dy dx this time. U prime, 2, times v sine 2x. Plus u v prime. Okay, so what's the derivative of sine 2x?
Cosine 2x.
Cosine 2x times 2 because of the derivative of 2x. This 2x, not that 2x. Okay, so let's just rewrite that one more step. 2 sine 2x plus, what would I make that? 4x cosine 2x. Are those, can I add anything, combine anything, do anything with that? No. Okay, all right, what about the next one? Sine squared x. Bring a 2 down. Okay, I might at least mentally want to think of this as sine x squared. Now, normally we'll shorten it and put the squared with the sine, but those mean the same thing. So that's a little bit shorter way of writing it, but if I'm doing a derivative, I'd kind of rather think of it or write it this way. Because now I see, oh, that outer function is the square, so I have to take care of that part of the derivative first. So I'm going to bring the 2 down times sine x, and I know we probably wouldn't write that, but I'm going to put the 1 there just to show that we subtracted 1 from the exponent. Now, chain rule, take the derivative of that inner function. What's the derivative of sine? Cosine. So I would just leave it 2 sine cosine. Okay. All right. Whew. Negative sine squared x squared. Chain rule and product rule.
You do the chain rule with the sign.
Could I or should I rewrite this maybe like I did the previous one? Okay, what's being squared? The sine of x squared. Okay, so let's definitely rewrite this one. Y is negative sine x squared squared. Okay, should I have put the negative inside the parentheses? No. Think of that as just a coefficient of -1 out there. Okay, so now outer function is this square. So for the derivative, because I have sine is being squared, but it's really the sine of x squared being squared. Same as up here where I changed it and I put that squared outside of sine x. Here I'm putting this square outside sine x squared.
Oh.
Okay. Okay, so let's bring the 2 down just like we did before. So that's going to be a -2 out front times sine of x squared, technically to the 1. I'll write it just so we can see. Now I have to take the derivative of what's inside. Okay, what's the derivative of sine x squared? So sine x squared. And one more chain. What's the derivative of x squared? 2x. That one has 2 chains attached. Okay, so outer function, the power rule of 2. -2 comes down front. This thing is now raised to the 1. Now I have to take the derivative of this. So that's derivative of sine is cosine of that function. But now I have to take the derivative of the x squared. Okay, can I combine anything out front?
Could you do the 2 and 2x?
Yeah, let's put a -4x out front. And then I have sine x squared cosine x squared. Is sine x squared cosine x squared 1?
No, because the rules when they're subtracted or added. It's plus.
It's sine squared plus cosine squared is 1, right? That trig identity. All right. Find the derivative of x sine square root x.
Could you just turn the square root of x into x raised to the 1?
I would. x times sine x 1/2. Okay, what do I need to use? Product rule. Product rule. U and V.
So do you do the product rule first, or do you do the derivative?
Well, the product rule is how we do the derivative, but I will have to use the chain rule when I get to V prime, because that's two functions. So I'll have to do the derivative of sine, then I'll have to do the derivative of x to the 1/2. Okay, so let's tackle this. U prime 1 times V. Now, when I just write sine x to the 1/2, I might leave it like that when I'm just bringing down V, plus U V prime. Okay, so what is the derivative of sine x to the 1/2? Cosine x to the 1/2. Okay. Let me finish this out and then I'll explain why it's not what you said. Okay, so that's, I'm doing V prime, so derivative of sine is cosine. But now I have to also take the derivative of x to the 1/2. 1/2 x negative 1/2. Okay, so what you were wanting to do is if I had cosine to the 1/2 of x, then you were wanting to first of all bring that 1/2 down, but it's not cosine that's raised to the 1/2, it's just the x. Okay? All right, can we do anything with this?
You could just put, you can probably just get rid of the line.
I think I just might move that 1/2 to the front of this, and that's, ooh, I see one thing. Can I multiply x times x to the 1/2, or negative 1/2?
Yeah. It would just be x to the 1/2.
Yes, because what do I do if I have the same base, add the exponents? And this exponent is positive 1, and 1 plus negative 1/2 is 1/2. I like that one. So that becomes 1/2 x to the 1/2 cosine x to the 1/2. Ooh, okay. So we might want to leave it like that. But what if I just change the x to the 1/2 to square roots? Would that look neater? I kind of think it might, but let's see. Plus 1/2 square root x cosine square root x. So I see how I got there. Okay. I don't like that one. Kind of cool, kind of cool. Any questions? Ooh, throwing lots of rules at you. All right. Next, cosine x square root tangent x. Would you rewrite it? Yeah, I would. Y equals cosine x tangent x to the 1/2. Because tangent x is the whole thing under the square root, so that whole thing has to be raised to the 1/2. Okay, where to go from here? Product rule. Okay, with the chain rule, you got it. Okay, so y prime. U prime negative sine x. Now, when I just write v, I might want to stick with the square root form. So that's u prime v plus u. Okay, here's the tricky part. V prime. How do I find the derivative of tangent raised to the 1/2?
1/2 tangent x -1/2 times
That's it. Okay, see if there's a question on where any part of that came from.
Okay, so I'm just confused on why we keep like finding the we found the derivative of tangent I don't know.
Do we just keep going?
Yeah, like do we now find the derivative?
Okay,
of
so
secant
did
squared?
we find the derivative of all of these in the original function? Yes. So we're not going to keep finding the derivative of these now unless I'm looking for the second derivative, which I'm not going to be that cruel to you. So yeah, once you have exhausted all derivatives in the original function, then you're probably finished.
Okay, so but why did we find secant squared?
Okay. Let me write this out. This was u prime v plus u, all of that is v prime. So we had to bring the 1/2 down. Tangent is now raised to the -1/2. We subtracted 1. But now we have to take the derivative of tangent. Chain rule. It said that's where the secant squared came from.
Okay, because we found the derivative of like the outer.
Exactly. This part's the outer. There's the inner. Okay, can we do anything to clean that up? You might want to write that as a radical, but it would be located where? On the bottom. Not of all of this, just of that term. I may leave that one. You want to rewrite it? Okay.
Yeah.
All right, negative sine square root tangent. And if we're going to rewrite it, I'm going to go ahead and bring that 1/2 cosine secant squared out front over square root tangent x. And what about that 1/2 in the numerator? I could really just put the 2 in the denominator. Didn't do that. Let's see. I'll do that here. There we go. Yes.
On a test, if we have both of these written and one of them's right, and we just do it wrong, second time, will you accept the first one?
Okay, so that's a really good question because when we grade the AP exam, we are instructed that if you have this answer right, but you keep simplifying and it's wrong, it's counted off.
You don't get
So
just don't simplify. So don't simplify if you don't.
I know. So that's why I'm saying like fractions don't have to be simplified. Like unless it's something that you're super confident on, I would stop.
So just the y prime that you have up top. That's it.
Like that would be good enough. I like to keep simplifying in here just because I think the whole algebra aspect of it is kind of fun. But if you take the exam, I would stop at that.
So if you simplify,
Only simplify if the directions say leave in simplified form, which I don't remember any problem requesting that. And same goes for units. You do not need to put units with your answer unless the directions say indicate units. Then that means that one of your points is coming from just the units.
You get my exam.
So yeah, they're very, very specific about that. So, and I can't tell you how many papers I've graded where they had the right answer and then they kept simplifying and went off track and then they get penalized for that. It's just like, dude, stop. Just stop there. But you've been drilled for years and years and years to simplify, simplify, simplify. So I know it's hard not to. But yeah, on the exam, I'd say don't simplify. Even if you had 5 over 10, I would leave it. Okay, find the derivative of this one.
can't you raise it to 1/3?
Yes, I can, and yes, I will.
And And then you can do the chain rule.
We are indeed going to need the chain rule.
Please don't say that.
Okay, so no derivative has been taken. I've just rewritten it. Derivative would be 1/3 is that outer function. Okay, we're going to get so good at adding and subtracting fractions. What is 1/3 minus 1? Don't touch that calculator. Negative 2/3. So think of 1/3 minus 3/3 is negative 2/3. Okay, are we done? Of course not.
Now the inside.
Now the inside. What's the derivative of tangent 3x?
Secant squared.
Secant squared 3x. It's like
And then you multiply by 3.
times 3. Because we didn't take the derivative of 3x. Oh, I do see one thing that we should simplify.
The 3.
3 times 1/3 is just 1. So I would leave this tangent 3x to the negative 2/3 secant squared 3x. Okay, how are we doing? Okay. All right, just 3 more. Secant of x squared minus 3x.
So would you first find the derivative of secant? Oh, you have to do a product rule.
Okay, what is u? Just the word secant?
Secant.
Secant without something behind it is meaningless.
So
It's like saying square root. Like square root of what? Secant of what?
We could
is it just secant of x squared minus 3x?
Yeah, it's just secant of this. No product rule here. If that was secant x in front of the parentheses, then we're in product rule world. But this is just secant of something. So what's the derivative of secant? Y'all just told me a minute ago.
Oh, secant tangent.
Secant tangent. Okay, so this is secant of something. And the derivative of that is secant of that tangent of that. So derivative of secant, secant tangent. There we go. Whatever's in the parentheses has to come along with it. Times 2x minus 3. We haven't taken the derivative of that inner function yet, the x squared minus 3x.
Just do that once.
Yeah, just once. Okay, is that okay to write it like that?
No, parentheses.
Yeah, if I don't put parentheses, then all of that's multiplied by 2x, and then I'm going to subtract 3 from all of it. Put those in there. And I would do nothing to simplify that unless you just wanted to bring the 2x minus 3 to the front. But if you did, leave it in parentheses. All right, how do we feel on that one?
That's pretty good.
Okay. All right, 10. Oops. Cosine x, sine x minus x. Product rule for sure on this one, because that is a function of x and a function of x. Okay, I'm not going to say anything. Y'all do it, and I'll do it, and we'll compare. Check this first step. Are we okay with this? Can I simplify?
Just get negative sine x squared
Okay.
minus plus.
How would I write that product right there?
Cosine x squared.
X squared
X
plus
sine
x.
I'll put x sine x. And then that would be cosine squared minus cosine. And at first glance, I thought, oh, this is beautiful because I'm going to have a sine squared plus cosine squared, which is 1. But that negative messed it all up. I know. That would have been so cool.
Yes, that's the code.
All right, so let's, I don't know. You just want to leave that one? No? Okay, if you don't, then I just don't see anything that will combine or negative sine squared x plus x sine x plus cosine squared minus cosine.
So there's no like chain rule with this.
No. That was just straight up product rule. I mean, you could say, okay, now take the derivative of the x, but that's just 1. Okay, last one. Find f prime of x, negative cosine x over 1 plus sine. Quotient. I don't think we've done that yet today, have we? All right, y'all do it and I'll do it.
Look at you.
Do you see it?
Yeah.
Oh. Pretty. Can I reduce? It looks like I can, but because that's sine squared and that one's just sine.
Where did that come from?
My sine squared plus cosine squared is 1. Oh, that's just sine. No, I messed up. I messed up.
Yeah.
Woo, now it is awesome. Because look what happens.
Oh, you can do that.
And then you can even
Yeah, that's 2 factors of that.
make it
Think of it this way. 1 plus sine. Oh, this one is so satisfying to end on. What's left? Oh, that's a nice one. Question? Okay.
My brain has brainitis. My brain
Your brain is so much better off now. Okay, we're doing the circle problems again.
Last one was better before this.
just can't look one of those out there.
Yes. Let me stop my video. I will put the answers up here. Actually, let me put them while I'm still recording, and then they can check.
Just angle like this.
There we go.
And did you see the video I sent you? This one?
Slide that up. Okay. On the flip side. Uh-oh, that was the wrong page. Was it? No, that was right. And then this one. Answers. answers. Okay.